What is Raman spectroscopy? Before we get into that, let us look into how light of considerable energy affects a particular atom or molecule.
Molecules or atoms can only possess particular amounts of energy or specific energy levels in which they are stable. So, when a light of particular energy interact with an atom or a molecule, it absorbs that energy and goes into a higher energy level. If the energy matches that of any of its stable levels, it stays there. If the energy is in between these levels, then it returns back into its former level by releasing the energy. In this scenario, when the atom or molecule release this energy, three things can happen. In most cases, the atom or molecule release exactly the same amount of energy it absorbed and goes back to exactly its earlier level. In a sense, it is like the incoming light just bounced off, or we can say scattered elastically. The other two cases are in minority, and that is what is important for us, the inelastic scattering, and that is what Raman scattering is all about. So, sometimes the atom or molecule only release some of the absorbed energy and stays in a higher energy level than it came from. This is known as Stokes-Raman scattering. In the converse case, it release more energy than it absorbed and goes to an even lower energy level than it came from, and this is known as the anti-Stokes-Raman scattering. So in short, the first type of scattering, which happens largely, is called Rayleigh scattering, and the other two, which happens less, is called Raman scattering. That is all about Raman scattering. So how does this helps in identifying molecules? More specifically, how is it used for spectroscopic application? By obtaining the difference between the absorbed energy and emitted energy, the Raman shift, or simply the energy level of the molecule, can be determined. This Raman shift is unique for each molecule, so it acts as a molecular fingerprint for each of them. Let us look at a few Raman signatures of particular molecules to get a better idea. So that's how Raman spectroscopy work. Hope you found it informative, and thank you for watching.